Okay, so we're going to talk about how to figure out what species are present when a substance is dissolved in a solvent. In this case, the solvent is water, and we're going to figure out whether or not methanol stays as methanol when it's dissolved in water, what other species might be present in water, and we're going to do the same thing for dinitrogen oxide and for copper 2 iodide. So for methanol, that is a covalently bonded compound. All of those elements are held together by sharing of electrons, and water, even though it's a polar molecule, is not going to rip them apart. So almost all of those methanol molecules are going to remain as methanol molecules in water. So we are going to write the major species coming from methanol is just going to be methanol. It's not going to be any sort of pieces or fragments or ions from methanol, but just whole methanol molecules. And there's also going to be water in there because that's the solvent. Nitrous oxide is going to be a little bit different. Let me throw the water in there. Okay, so the only difference though for nitrous oxide is going to be that it's water and nitrous oxide. The compound itself does not get dissociated into ions. The reason I know this is because it's a covalently bonded molecule. Those are both nonmetals, and if you see nonmetals in a compound, they're not going to be ions. So it's not like the nitrogens are going to be plus charged and the oxygens are going to be minus charged. In fact, since they're both nonmetals, you should expect that they're going to be covalently bonded, and therefore the water's not going to break it up. It's not ions, it's shared electrons, it's not a plus and a minus charge of some kind being held together as a salt. In fact, it's the sharing of electrons. So we would actually write N2O as the other species in water for nitrous oxide because it doesn't dissolve into ions. So copper 2 iodide is a completely different story. Copper itself is a metal. Iodine is a nonmetal. You would expect that a metal nonmetal compound would have a cation. If we go to the periodic table, you don't have to take my word for it. We can find copper. Here it is. It is a metal. It's in the transition series. It's to the left of the metalloid, so you know it's a metal. It's like over here. And conversely, here is iodine. It is a nonmetal. So it's going to have a minus charge. It's going to steal electrons, and copper is going to lose electrons. It'll have some sort of positive charge. And our formula actually says that it's copper 2. So we could put a 2 plus charge after the copper, and that's going to be the ion that dissolves into water or dissociates into water. And you're also going to have I minus ions that come from the copper 2 iodide ionic compound. So those are the two species that form. You're also going to have water because water is present as the solvent. And that's really all you have to do for this sort of a problem that asks you to predict the products of dissolution. You just have to figure out whether or not anything's going to be dissolved into ions, and if so, then you are going to have to figure out what those ions are.